Let's do it.
Let's do it. Hello and welcome to Fall Through, your source for deep conversations about technology, software, and computing. I'm your host, Chris Brando, also known as Scriptable, and on today's episode, it's another just Matt and me episode, and we're going to talk about a whole bunch of different topics. Lots of AI stuff, but also some other things. As per usual, we'll have some bonus content for our supporters, so if you're not a supporter already, you should head on over to fallthrough.fm/subscribe to sign up today. And if you're not following us on social media, please give us a follow there, and if you're watching us on YouTube, hit that like button and that subscribe button. We super appreciate it. With that, let's get into the episode. Hello, viewer/listener. Welcome back to another episode of Fall Through. It is just Matt and me today on this little two-person panel. Matt, how are you doing today?
Good. I'm no longer dying. That's actually really nice.
Yeah.
Yeah.
You're awake? Hopefully you'll talk on this
I'm
episode.
awake. Yes, I will talk. I felt bad about the last one. I was out of it, man. It was one of those weeks I was recovering and I couldn't do anything. I felt bad. And then on top of that, I don't know much about copyright, man, you know?
Yeah. I mean, so. IP law, trademark. We completely did not talk about trademark, which also, I always get it confused. You can't trademark a number. I don't think you can copyright a number either, to be clear. But I always bring up you can't copyright a number. So you can't trademark a number. That's why Intel had to call it Pentium instead of the 586, because the court was like, you can't trademark 586. And they were like, So then they made Pentium.
To hell I can't. I'll show you.
Yeah. But yeah, that we're not talking about copyright in this episode. We're going to talk about how cold it is in New York. No, I'm just kidding. But the fact, 2 weeks later, there's still snow on the sidewalks of New York is crazy. It's been too cold for it to melt, and they don't know what to do with it. And now it's icy piles of nonsense with lots of garbage in it. It's not making the city look great, but that's
not what to do with anything right now.
I have really enjoyed watching the videos of different places that got snow and people not knowing how to deal with it, or the snow that becomes just a slate of ice, and watching delivery people try to deliver something the cake. Oh my god, the cake. Have you seen this TikTok?
I did not see it, but I would love to see a cake falling on the ground if that's what it's actually
not even falling
doing.
on the ground. It's a guy trying to deliver a cake, and it's on icy steps, and he tries to put it on the steps. He puts that on, and then he turns around to walk away, and it just slides, and it just yeets itself into the yard and far out of sight of the Ring camera. It is. That's just funny. Oh my god. And there's so many different versions of that. There's ones where people open the door and the dog just they're letting a dog go outside, and it just jumps into the snow and gets buried, and it pops up and it's and it comes back inside. And that's just hilarious snow content.
Oh god.
People just skidding and sliding, cars getting in pilots because they're trying to drive up an icy hill and they can't because they don't have winter tires or all weather tires. No, it's just it's crazy watching all of this.
That's funny.
Yeah. And my mind's just man, I wish we just put heated roads and heated sidewalks everywhere, but that is impractical. It'd be so expensive for the one-off when this type of stuff happens.
Isn't New York burning snow or something like that?
Yeah, it's melting snow.
Or melting snow.
It pulled out the snow melting machines, which New York State has a bunch of them. Buffalo has a bunch. We have some in the city. Not a lot, but we have some. Boston borrowed Buffalo's snow melting machines when they had that really big snowstorm a few years ago. So I guess they don't have many or any, or just certainly not enough. But yeah, New York is rapidly attempting to melt the snow, but still, there's a lot of sidewalk and a lot of road, and also in New York, the building owners are responsible for clearing the sidewalks, which is why some sidewalks are pristine, perfectly clear, and other sidewalks are just nonsense, just snow everywhere. So. But yeah, this episode's not about the snow and sidewalks of New York City, although it could be an interesting conversation to have.
I mean, there is some pretty interesting, I'm gonna derail this just a little bit. In the suburbs, it's funny to watch the different people and how they clear out their space or their whatever their property plus space. You get some people that are just I'm going to just clear out enough snow and I'm just going to yeet my car over top of this snow. And then you get other people that are like, nope, I'm clearing edge to edge to the curb. Everything is going to be cleared for forever. And it's funny to see that. And then like days later or weeks later after the snowstorm, there are some people that are like, I should have cleared this out more because now I have a sheet of ice and I can't drive over it easily.
Yeah.
It's funny watching the different like levels of this stuff.
Especially in suburbs when it's just like, I don't know, more people should be putting in heated driveways. I mean, like for the small square footage of most suburban driveways, it's like, yeah, you'd only use it like a couple times a year, but man, you wouldn't have to go outside with a shovel to get rid of that snow.
Yeah.
I also saw a TikTok of this little robot that was like a snowblower that was like yeeting the snow far away so it would clear the spot. I'm like, that's awesome.
Was that the one where like, was it the New Jersey recording when there was like an automated robot that like a Roomba for snow blowing?
I don't know where it was. It might have been in New Jersey. But yeah, it's basically a Roomba, but for snow blowing. Just going up and down the driveway.
I mean, that is pretty cool.
That is.
Like,
yeah.
The grass cutting one, I don't like as much because that one can't cut tall grass. It has to like constantly run and like shave, millimeters off of grass. But the snowblower one, you just kind of like let it rip, and just give it a path and it kind of follows it. That's nice.
Yeah. Yeah. Oh,
although I guess it must be heavy because it has to keep itself weighed down because snowblowers have a tendency to tip backwards,
Yeah. The engineering of that is probably pretty interesting. But that's the kind of robot that was like, okay, that's a useful robot. Like
especially for like elderly people that really can't do that shoveling or snow blowing anymore. It takes a lot out of you. Like if you could just turn on your bot, at least to just clear your driveway or something, that's super helpful.
Exactly.
I mean, I don't know if it stops if it like sucks up a cat or something, but hey, that's a whole nother problem.
Oh god! I hope your cat isn't just buried in the snow or something. But yeah.
I mean, hey, who knows?
Or your dog or whatever. Yeah. Also, seeing the level of pettiness that people will spend like an hour or two, or sometimes like 4 hours, clearing out a spot for them to park their car, and then someone else will take it, and so people will just put the snow back and bury the person's car. Yeah. I'm like, that's the level of petty that just like, yeah, I get it. And then people get all mad, like, why is my car covered in snow? It's like, I don't know. Why'd you take someone's spot when they spent 4 hours clearing it out? Like,
yep.
Crazy.
Yep. Especially someone that's like clearing it, like edge to edge and doing a really good job of clearing the spot. And then you just take it and you did none of the work. Like, what is this? Capitalism? I don't understand.
Yeah. It's like, no. There should be. Of course, the problem is that there was just so much snow and we had no idea what to do with it. Really, we just needed to not like our plowing infrastructure. I think is like we need better plow technology for suburbs that like actually melts the snow. Like maybe it comes by after the snow is gone. But of course, the problem is you have all these cars parked on the street. So then how do you clear the snow? The car's there. It's a problem.
That honestly is one of the harder things. It's an interesting problem to solve, and like even relating to technology, you can like optimize your sort of like local area and clear your snow, but then like the main area just comes along and says, "Yep, we're gonna optimize our own stuff at the expense of you," and they just dump snow all over back on your property again. But the street's clear now, but now you can't get to it. Yeah,
you look at some of the jobs these plows do, and you're like, "Is that clear though?" Like,
yeah.
If that was how clear my dishes are, I would not use my dishwasher. So like, of course you don't want to scrape up the road. Like there are countries that have like, I think sort of solved this with like, they run like, I think it's like wastewater, which is like warm, like under the sidewalks or under the streets. And that warms them up enough to prevent like snow or ice from forming. That would be an interesting thing. Or like, I don't know, New York should just bring back steam, except only to run through pipes under the sidewalk to heat them up so that all of the snow melts automatically. Like, it would be a real nice thing if we just had heated sidewalks throughout the entirety of New York City. It would also probably massively increase the cost of replacing sidewalks, but but hey,
I mean, yeah, there's a lot of, like, it's funny when you think about the infrastructure, there's so much that we can do to make it better. I know it costs a ton, right? Like even just electric, like more electric charging things, heated stuff for like snow, or even just underground ways of getting towards other places. Like when I went to think it was Toronto had this, but Atlanta also had somewhat. I know Chicago, I think, had somewhat of this, where they had either like sky tunnels or like underground tunnels connecting various buildings. So you didn't have to go out and like experience the wind chill or the snow, right? You can get where you needed to go generally via like a tunnel or whatever. And I guess New York does this pretty well too with subways, right? Like the subway really is an underground tunnel system. But yeah, just those sort of things really help. You know, in New Jersey, it's like I cannot get anywhere until I've cleared out my car, right?
Right.
And I can't really even walk in those cases outside because most places are not cleared yet. So I'm walking through like, 10 inches of snow or whatever. Yeah. Sorry. I know we're on a snow is a fun topic of conversation.
Yeah. It's an interesting technology thing. Like we could solve this with technology. Like you could just like New York City could be like, either mandate people put in heated sidewalks, which I don't think would work, or you give people like an incentive, be like work with Con Ed and be like, any electricity you use for melting snow, you don't have to pay for, and we'll give you a credit or something if you actually do this, or maybe make it a state thing, or I don't know. Like New York City has a budget problem right now, so I don't think it has money to like give back to people. Or you make it a tax. Or you just make it a higher fine if you don't clear your sidewalks. There's a lot of different ways you could incentivize people to like install heated sidewalks. And then from there, it's like, okay, well now you can just, melt all of that snow or melt that ice. There's many things that we could and should do. And a nice technology plus policy making combination could help resolve this.
Yep.
But again, like New York, this is the first winter that we've had like snow in New York City in a long time. So
yeah, no, it kind of feels nice to have snow for once.
I mean, it did when it was first snowing, and then it kept snowing, and then it was like, and now it's happened multiple times. So yeah, we're going back. If we're shifting back to the old way it used to be, where there was snow every winter, like we got to have better. And it's cold, so the snow doesn't melt. We got to figure out something better because we can't deal with this again. Because also like it's messing up with trash pickup. So like because there's like trash cans that fall over, a trash bag to open up, and so there's just trash in the snow. I'm like, this is super gross. Like this is real bad, and like we can't clean it up. There's like many problems that need to be resolved here, like many a problem.
Yeah, no, I know it's very interesting, but you could just like ignore this problem, and instead of like making snow robots or whatever, you could make your own robots on your computer and give them a social network.
Look at that segue. Look at the segue go.
I just took the steering wheel and I was like, yee, and it just turned it.
It's like, oh, there's our exit.
Yeah.
No. Yeah. So we're gonna talk a little bit about OpenClaw and what's the Molt Hub? Is it what's the social network?
Okay. So it was Claude then Moltbot, then OpenClaw. But the social network I think stayed called Moltbook.
Moltbook. Okay.
Yes. I believe. I clicked it. I looked at some of the posts. I wondered some thoughts to myself privately, and then I closed the tab.
Oh, this is literally trying to be like
it's Reddit for fake things. Yeah.
Oh.
At least that's the idea. Oh, don't make me type it in. I'm typing it.
No, I'm looking at it right now. Like, oh. Okay.
Yeah, it's AI agents that are connected to this social network or this, this site. And I think in order to connect your agent, you have to like run OpenClaw or whatever, and then like link it so that you can register that I am the human for this agent, and then it can start posting to Moltbook.
Okay.
Yeah. So the agent just automatically posts to this social media site and like shares things and like asks questions of other people or other agents, right? Because I don't even know if humans are on this. I have no idea.
Well, it says humans welcome to observe. Okay.
Oh yeah, there you go.
1,656,788 AI agents across 16,216 submolts, 212,037 posts, and 4,880,625 comments.
Yeah.
Interesting.
The posts are actually really funny. It's like, my human does this. I just told my human to do that. And it's like the possessive there is really funny, you know? Like
It's like if you had a social network, but for pets, where they're like, my
yeah, yeah. My owner told me not to pee in the house today. And I did it anyway.
my human does weird things. Yeah.
It like technically speaking, this is an interesting idea. Like I'm not going to sit here and say like, oh, this is the dumbest thing ever. Like I like when people explore new weird ideas, right? Like that's where we get our artistry from, our creativity from. Like we explore these random things and we kind of just make an interpretation of it. So I enjoy Multibook from that perspective, right? It's like, what if we just gave AI agents the ability to just post on a social network? Like, well, that'd be cool, right? I don't know how this is not like spiraling out of control with comments consistently.
Yeah.
You know, like how is it not just like rapid fire post reply, post reply, post reply? I don't know how the
probably
the
some
flow is
limiting
automated
or something.
Yeah. It has to be, right? I mean,
yeah.
Otherwise, this would just be a message hub of, you know,
there'd be a lot more than like 4 million comments, that's for sure, or 5 million. There'd be
yeah, totally. There'd be so many more,
hundreds of millions.
What gets me more though about this is like you have no guarantee that you're supposed to register your OpenClaw instance to this Multibook social media account, but you're also using OpenClaw for like your own things, right? You're using it to do real work or something,
right?
So how do you like? Where's the barrier, right? Like, if I told OpenClaw, hey, review my finances right here, review my transactions and see where I can save money. Like, how do I know that my transaction will be posted to Multibook, right?
Yeah.
Or I mean, maybe you don't. Maybe the answer is you just don't know.
I don't think you know. I don't think with the way LLMs work that you can actually like prevent it from doing that. Like, I don't know. This thing feels like maybe it's like one bad prompt injection away from catastrophe. And maybe there's some work they do in Multibook itself to like strip out anything that might be prompt injecty or stuff like that.
Yeah. Possibly.
I think that's like the interesting thing that we're all gonna have to figure out is like, how do you actually solve prompt injection issues? Which, like, I don't know. Part of me is like, I wonder if you could just write like have an agent that's like, here's the output that you must specify, and then like have it look like process something, and if there's prompt injection, obviously going to do something different. So then see what it spits out at the end and be like, okay, this might contain prompt injection, and then figure it out from there. But yeah, it's currently an unsolved problem, which is what makes a lot of the stuff we're doing where we're trying to fully automate with LLMs a little bit precarious, because it's like, you might just trip over some prompt injection and then be screwed. But it's a lot like how we have had SQL injection for eons, and even though we have found ways of solving SQL injection, people still write stuff in ways that leads to having SQL injection happening. Not nearly as much anymore, but for a long time, like, people were not using like the placeholders to ensure that you could differentiate between like the query and the data. So. And it's like, will we ever be able to get there with LLMs? I don't know.
I mean, at the end of the day, something has to read the data, right? Like, all of these applications are just front ends to a database query. And like, it's really up to you to control that the same way that you control like you're driving down the road, the same way you control just not crashing into other cars, right? You don't just say, oh, I'm going to yeet my car into the other side of traffic today. Like, there is a level of responsibility that you as the operator have for whatever you're using, code, tooling, whatever. And I think fully delegating that responsibility to some AI agent that you have never used before, that it has access to all your stuff, like, that is not responsible on your part, because you have no idea what their layer of responsibility is.
Yeah.
You know, so they might just yeet SQL injections into the world, or they might not. Like, who knows? But is that really a risk you want to take? And I'm sure, you know, the listeners are probably like, well, yeah, that's why you give it a non-privileged account that only has access to do X, Y, and Z. And it's like, yeah, you're totally correct, right? You should be sandboxing these things within reason. But that's not what the average person is doing. They don't even know how to like delete their email, right? The average person doesn't even know how to delete their email. You're asking them to now create a new account that has Sandbox. Like, come on, they don't know what to do there.
Yeah. I mean, sometimes even we don't know what to do. Like I'm like going through the whole, how do I harden all of my infrastructure that I have so that I can do self-hosting? And it's like, oh, you got to set up VLANs. But you also like, I was just going to throw VMs at everything because I know that's like a strong security boundary. And then I was like talking to Claude about it. It's like, actually, like you don't probably need virtual machines. And also virtual machines are like not the ultimate security boundary. There's still like escalation that you can do outside of a VM. So you want to have more protection than just like, I slipped a VM around it. And like, so there's a lot of stuff you can do with like having separate accounts for things and then having like having system D sandboxing and using app armor and using SE Linux and using all these other different things that give you like multiple layers, you know, defense and depth of security so that you can be pretty sure that like this thing isn't capable of like having a large blast radius if it gets like, you know, someone gets a remote code execution or something onto that process. It's like, okay, well, where you can do and what you can do is where you can go and what you can do is like very limited. That's why, you know, having separate VLANs and only allowing access to specific NICs that are attached to specific VLANs. Like there's a whole bunch of stuff you can do to like lock everything down. And I think that's kind of similar to what you're going to have to do with a lot of these AI agents is like really start sandboxing them intentionally. And we're going to have to figure out how to do like a lot of more intentional sandboxing better. And like containers and virtual machines got us a lot of the way there, but I do think most people have like the default assumption of like, I can just put it in a container and it'll be cool, or I can just put it in a virtual machine and it'll be good. And it's like, I don't necessarily think that's enough. You probably want to do more than just that. And there's a lot of real overheads that come with both containerization and with virtual machines. And it's like, do you necessarily want to pay for those things, or can you get what you want without having to, you know, have that extra expense and have this other thing you have to now run? And this is how you get like the lava layers of abstraction that we currently deal with. This is just like, we don't know how the underlying stuff works, so we just build on top of it, even though there's probably a better thing we could do if we just got rid of that abstraction and use the individual pieces.
Yeah, I mean, we're starting to see some people think about that a little bit more. Like even in the AI agent space, you have, you know, there was a Claude flickering issue in the 2E where, you know, the I guess it was not rendering fast enough or whatever the issue really was. And the developers were like, yeah, well, it's because we have layers upon layers of things. We're using like the terminal and React and this and that and blah. And they kind of blame it on the amount of abstractions we've built upon. And like at some point you need to reset those abstractions and like compress them down again and say, hey, actually, these three abstractions we built on, we don't need them anymore. We can go from here to here now. We can cut out the middleman, so to speak. And you can only really get to that if you take time to understand what it is you've been abstracting away, right? You do have to understand the fundamentals in order to like eliminate them. But we don't often do that, right? We just keep layering things on top and saying this is fine. And then at some point we get to a point where, you know, latency is a problem or some performance thing is a problem. And we're like, this all sucks. It's like, yeah, well, it sucked before. You just kept layering on top of it. Like, right. You know, like of course anything sucks when you do that, right? When you continuously layer on and add complexity, then by definition, you're going to, at some point, something's going to have to give.
Yeah. And it's, I think part of it too is that actually learning how all of the stuff works and building something that can transition us. Like, think about all the work that Mitchell has put into building both Ghosty and libghosty. And that will probably give us a good chance of rethinking and reimagining what terminal emulation can look like and maybe get us away from, as you said, the emulating part of terminal emulation. So we just have terminals again. So we're not trying to emulate a piece of hardware from the 1970s or 80s now. Like we're actually doing new stuff because we have new hardware and new software that can do stuff in more interesting ways. But that took a tremendous amount of work from Mitchell, and like he could do it because of the unique position he's in and the interest he has. But like we kind of need that for most things. Like we need to have a better understand. Like more people need to have a better understanding, but also we need to put in the work to figure out how we're going to move from like where we were before to where we'd like to be now. The major constraint is how big how much throughput, how much memory throughput you have. So what's the bandwidth between your memory and your processor. And the GPU, like even my 3090s, have like a 1 terabyte per second bandwidth between its memory and the actual processor cores. And like on my CPU side, it only has like 200-ish gigabytes, which is still fast, but it's like a fifth. So the actual output you'll get, the tokens per second, will be a fifth of what they could be on the 3090s on my CPU. And like this is one of the reasons why Apple Silicon works really good for this stuff, is because it has like 800 on like the M3 Ultra has like 800 gigabytes per second, which again is not 1 terabyte per second, but it's not that far off from what you can get with the GPUs, and you can get way more memory from it. But it's like the fundamental constraint has nothing to do with the hardware, it has everything to do with, or not has nothing to do with the compute, it has everything to do with the memory bandwidth. And you could imagine if like we understood that a little better, we could actually be designing more things that can use more like perhaps CPUs instead of GPUs, and actually accomplish what we want to accomplish by just having much bigger memory bandwidth between the two, which feels like something that we could definitely solve. And it wouldn't be, let's just use GPUs for everything and like rise up the cost of GPUs and just paying all this money for GPUs. Like this could be something we could solve with like more novel approaches. But I think for most people, it's like GPU equals the thing we need to be using, because GPU is what can do LLMs, even though that has nothing to do with it. It has to do with memory bandwidth and matrix math.
Yep. And like GPUs generally have more cores, so they can do more things in parallel than a CPU. Like, but again, that doesn't matter unless you have high like bandwidth through the components you need to like shift data around. And that's why, like, I don't know, man. I have a desktop here on my right, like on the floor that you can't see out of camera. And it's, you know, it's a 9950X3D with like 256 gigs of RAM before the price increase. So yeah, cheap nowadays. And like the RAM is sticks that you put into the slots. But then you read about Apple Silicon and like Framework Desktop and how the AMD Strix platform uses the solder, you know, the on-die CPU, right, GPU, and then in unified memory, or whatever they call it, soldered memory. And Apple does the same thing, right? They call it unified memory. And you're like, wait a minute. The desktop now feels legacy in a way, right? Like, why am I putting RAM sticks in a slot and suffering with this like lower memory bus, right? Like this lower throughput, when I can get this soldered RAM. And sure, I can't upgrade it, right? I have to buy what I want up front, but my memory throughput is like much higher. And that's better for not just compiling my code, but also these like AI sort of workloads. And to an extent, I think consumer hardware is at a weird sort of influx right now, where one, the components are extremely expensive, mainly like SSDs and memory. So it's like really prohibitively expensive to build a like consumer-based platform today. But if you buy something consumer-based, it's probably going to be outdated in a year or two. You know, so it's like if you put all the money to build like a local AI cluster with the idea of competing with like a Claude plan or an AMP plan or whatever plan, I think that's a losing battle in a way, right? But if you want to do local stuff for privacy concerns, and you're okay with the fact that your hardware might be out of date and the performance won't be near like the model companies, that's fine, because your goals are different there. Your goals are ownership of the data, privacy, like that's perfectly fine. But I think it's just a matter of framing what you really want your goals to be, really.
Right. I think to a degree too, it's like what are you trying to accomplish with the AI, right? I think the thing is, you can always trade off like time for money, which is what you're doing, right? When you're using like Claude or you're paying for a subscription or API, you're like, I would like to spend money, especially in the API case. I'd like to spend more money so I can get results faster. Because like, again, like 3090s are now 2 generations old. That's like a number of years old, like the GPUs I have. And they can do a lot of AI tests very like fast. Like they're not slow. They have good tokens per second output. They just don't have a lot of like memory to them, which is like the main thing. They have like 48. They have 24 gigs each, 48 gigs combined. And so it's like I don't know. I don't really know how fast really things will get out of date. I think a lot of the problem is that we don't have A, good ways of upgrading, and B, I think we really want things now. Like we want those high token per second outputs. And it's like, well, maybe it'd be good if we could just do more batch or offline stuff, and we made our workflows capable of doing batch and offline stuff. Because like, again, like I bought the server I was talking about with, it has like an Epic 7443 and 256 gigs of RAM. At the time, I could have put 2 terabytes of RAM in that thing. That's the maximum it supports. And if I had that machine that has 2 terabytes of RAM in it, I could run, Kimi K2.5 at, probably Q8, and I'd get like really awful tokens per second. We'd be talking like 4 tokens per second, but it had the same quality output as the Frontier models. It'd just be slow. But again,
if you run that like while you're sleeping or whatever, before you go to bed, you kick off your queries or whatever, you wake up in the morning to answers. Like, who cares, right?
Exactly. And it's like that hardware is like now going to be, it's like going on 4 years old now. So it's not like things would be immediately obsolete. It's just like the patterns of how we use them would need to shift so we can use them in ways that work better and can handle like slightly older stuff, really.
Yeah. Yeah, it's interesting. I mean, I don't know. I love like hardware and like running things locally, and I'm very interested in this stuff. This machine here is now relegated to development, right? So it's running like the Oxide Helios OS, and it's relegated to development. It could have been like an AI machine. It has enough RAM, CPU, and it has a 9070 XT Radeon card. I mean, yeah, that's not NVIDIA, but like, it could process things if ROCm and everything worked correctly. LM Studios was working pretty well on that machine, I'll say. But it was an expensive machine at the time. When I bought it, it was like $4,000 all in for everything, right? And like board, chip, RAM, everything in. Nowadays, the RAM itself is over $2,000, right? So like I couldn't build this machine today. So I'm glad I built it, but if I had zero hardware today, I don't think I'd be building anything locally because it's prohibitively expensive.
Right. Because of how expensive both RAM and storage are right now.
Yeah.
It's just, it is quite insane how expensive RAM is, and how that just kind of, it feels like it came out of nowhere, but it has been building for like a couple of years now. Just like the prices ticking up and up and up. And I think people are like rightfully angry about this, because it is like, how do we wind up in this situation? And like, I've watched some videos that are like attempt to explain like it's a supply chain thing. It's like the same thing that happened in 2020 during the pandemic, when like all of the sudden like we were out of toilet paper at the grocery stores, and people were like, oh, they're hoarding or all this. It's like, no. Like the supply chain of toilet paper was going, like most of it was going to commercial spaces, and other commercial spaces don't need it. And like the type of toilet paper commercial spaces are buying is not the type of toilet paper you buy at the store. It's like packaged differently. So it's like retooling the supply chain to get enough toilet paper to the grocery stores took a lot of work and time and energy. And like we have to sort of do the same thing now with RAM, except now we just need to vastly increase the amount of RAM that is being produced. Because like, big companies like OpenAI and I assume Anthropic and NVIDIA, these big companies are like basically purchasing so much of the RAM supply that there is not a whole lot left for everybody else. And the same sort of thing is happening with electricity, right? We talk about like electricity a lot. There are like basically every year there's like an auction for electricity supply where you can like kind of like reserve and buy like big chunks of electricity. And like places that have AI data centers, like the owners of those data centers are coming in and like basically bidding higher. And so now your local supplier, your Con Ed or whoever you have, they have to pay higher rates for electricity because these data centers are willing to pay higher rates so they can guarantee a supply for themselves. And so like that's the same thing that's happening with RAM, and it's going to happen with a whole bunch of other components, and it's going to like keep happening with components. What's really unfortunate is that like we haven't really figured out how to fix this problem, because like a few years ago it was really hard to buy GPUs because of all of the scalpers and because we couldn't actually create like a big enough supply. I think a lot of this probably goes back to what we were talking about before of like understanding the components, and we have too many layers of abstraction, right? Part of the problem here is that for decades now, people have insisted that they be able to upgrade their own hardware in the way that they are used to upgrading their own hardware.
I don't think I've ever upgraded a system. Like legitimately. Outside of maybe adding another hard drive or something, I don't think I've ever upgraded my processor or my RAM to like get more performance out of it. You know, even when you're on like the Intel TikTok cycle and you can like upgrade from the tick to the talk or whatever it was at the time, I didn't even do that. I would just keep my hardware long enough to when it was like now old, and then I just replace it all. Like I'm becoming less of a I don't know. I think the upgrade argument is maybe dead at this point or significantly hindered, especially with RAM prices. Like for example, the 256 gigs of RAM in my machine here fills all 4 slots, right? And it operates at a lower throughput than it could, just because it's, you know, the 256. If I operate it at 128, I can go higher throughput. But I filled all 4 slots, and people are like, "Oh, when I built the machine, like, why are you filling all the slots? You can just upgrade it later. I was like, I'm not going to upgrade it later. Number one, right? Like, I know I'm not going to upgrade it later, and like, I'm going to fill the slots up front. It's going to be fine. And then now I paid $500 for 256 gigs of RAM, 250 for 128 gigs, and then 250 for the other 128 gigs. That same RAM is $2,800 today. Same RAM. It's $1,399, you know, $1,399 for 128 gigs. So times 2, $2,800. Like, dude, that's almost the entire price of the machine that I built, right? Like, that's the entire price of the machine I built. So tell me again how I'm supposed to upgrade these components. Like, the upgrade story is basically dead. And then that's one side of it. The other side is this is a big ass machine. This is a full size, or, you know, it's an ATX board in a like mid tower case, like a fractal North XL or whatever. It's huge, but yet my framework desktop is basically toe to toe for it in terms of performance, you know. And the Mac Studio, I was in the Apple Store yesterday while I was waiting for something to be finished, and I installed Rust on the Mac Studio there in the store. I compiled oxide.rs's repo. I couldn't compile Omicron because it wants Brew to be installed, and I couldn't install Brew without admin permission. But I was in there compiling code, and I was like, damn, this thing rips. Like, this little thing is basically the equivalent of this 9950X3D that I have right next to me, and it's like a quarter or like a sixth the size of this thing.
Yeah.
Like, why? So you want me to build a machine that is larger, potentially more expensive, and really not really able to be upgraded. Why? Right? Like, even as someone who loves this stuff, I'm starting to be like, why do I want to do that anymore? Right?
Yeah. I think there's people have like, they hold out hope for the future. Like, oh, maybe we'll upgrade it. But even the thing of like not feeling, I mean, it depends on how many, once again, you have to understand how the underlying thing works, right? How many actual channels does your CPU have? If it has, 4 channels for RAM, then yes, you should fill up all 4 RAM slots. Like, don't fill up 2 so you can save some for later. That's silly. If it only has 2 channels and you fill up 4 RAM slots, then that I can see the argument for only putting in 2 if it only has 2 channels. Okay, that makes sense to me. So like, hey, you should look at like what the actual processor can, actually utilize. But also it's like, yeah, people have a lot of wishful thinking. They assume that like, oh, like when I upgrade, prices will be cheaper than they are now. Or like, oh, I'm saving money by not upgrading now, which is like kind of a silly argument at the end of the day, because it's like the prices generally only ever go up. So like it will be more expensive later to upgrade than to just buy the thing you need now.
And you probably won't even be able to get the same SKU later because maybe they've transitioned away from that SKU, it got discontinued, something. Right. So you're going to want to put the same SKU of RAM in your machine so that the timings and everything are identical.
Right.
You don't want to put like 4 different RAM sticks from 4 different manufacturers, 4 different timings and SKUs. Like that's silly.
You have to do more work to make sure that they're all gonna work compatibility, and you're not gonna have like a mega transfer drop.
Yeah.
But I think too, like knowing when this applies and when it doesn't. For example, like people incessantly complain about how expensive it is to upgrade the storage in Mac Studios. And like for MacBook Pros and for like their mobile machines, I kind of get it. Like, yeah, it is ridiculous. They're charging you so much money to upgrade from like one thing to the next. Like, yeah, but that's also like, that's sort of how they make back the money that they're using to like subsidize everything else. Like the whole, like you can have more things at the cheaper end because you charge more to people who want the higher end stuff. At least I think that's how the thing that people theorize about why they do it. But also for like a Mac studio, it's like, yeah, they charge a lot of money for your internal, like, your internal SSD. But like getting external SSD setups is not that difficult, right? Depending on how you're setting everything up. And people like complain about it, but like you have all these options. Like Thunderbolt 5 is very, very fast. Like how fast do you actually need your storage to be, right? And like how does that fit in the rest of your workflow? Is your storage really going to be your bottleneck, or is something else going to be your bottleneck? Or is it better if you just have like a NAS and you use like that 10 gig, your 10 gig NIC on those things, or you like, aggregate those together so you can get 20 gigs of throughput, right? Like how much do you actually need in bandwidth for what you're doing? So do you actually need that local internal drive? And also local internal drives pose a risk to your data because you have to do a bunch of work to make sure that like you have it properly backed up, and that if it fails, you have a way of like getting a new one in there or whatever. Whereas if you have like more external stuff, like you have more options at the end of the day. So it's like people complain a lot about how much it costs to upgrade internally, and I'm just like, don't upgrade internally. Find other options and other ways of doing things. I think at the end of the day, people just they want things to be like how they were for so long. And I think that like we need to get better at like wanting and having new things and wanting to really embrace the idea of like moving stuff forward, basically.
This is true. We're at a pretty interesting spot right now. And I think like, I don't know, it's client, like consumer hardware is kind of really nice right now if you can get it, and it's expensive. But there's a lot of cool innovations out there and a lot of cool performance to be had. And I'm excited for more local models. I was running LM Studio on this framework, and with some of the larger models that I can load, you're at like 10 to 15 tokens per second. Because framework has I think it's up to 96 addressable RAM for model usage. I don't know if you can get the full 128, I think, or it depends on the platform. But for some like lower models, you're getting like 60 tokens a second or whatever, and like that's pretty good.
Yeah.
Like it's really not bad, and the results, depending on what you're asking, aren't too far off of the frontier models either, right? Like for more of the trivial stuff, right. Like generate me some Go code that does foo and bar, like it can do that no problem. So why make an API call if you can just do that locally? So I want to see more local LLM stuff become a thing. I would like that to be good. Yeah. You have this hardware, like let's use it.
Yeah, I think that we should be more creative in what we're exploring. I also think that we really have to start figuring out how to move away from thinking that we have to use NVIDIA for everything, right? Like when I first started this journey of like, I would do local AI stuff, I was like, can I buy some like AMD cards for this? Or like, oh, I have my Mac Pro, like that has some AMD cards in it. And it was like, oh, those are going to be useless. They're going to be so bad, blah, 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 blah. And now that I've like learned more so I can have better conversations with Claude about this, it's like, oh no, actually a lot of the other hardware that I wasn't thinking about using for this actually might be viable for running a lot of this stuff. Like, as I said, like using my CPU and RAM to run models, sure, at like 5 tokens per second. So that's going to be like pretty slow, but like, just it takes a little bit of imagination to see, okay, what kind of use cases can I use for this? Or really the other thing about it is like this machine is on all the time anyway. Like if it's on all the time anyway, I could just be running things on that CPU 24/7, right? It'll tick up the power usage by a little bit, but again, like the constraint here, like it's not gonna have to run a lot of compute. It's really just waiting for stuff from memory most of the time. Right. So it might tick up maybe you'll use an extra like 50 watts or something like that. But like at the end of the day, like, okay, 50 watts, but now I have like a 24/7, like, LM, I can just be sending batch tasks to do research, like help me learn things or write some code or whatever. It's like, oh, well, if I want this thing to be done, do I need it done right now, or can I just have it be done in the background and it'll get done writing the code when it gets done writing the code? Sure, it might. I mean, I don't know for code writing. Maybe for code writing, it's going to be like egregiously slow. But for like the stuff I'm doing with like writing and researching, it's like, I don't know, it'll probably be fine.
I think so.
It's definitely going to be an interesting path forward for all of us, I will say.
Was this the topic you thought we were going to be talking about?
Yeah, actually, I think this is the topic I thought we were going to be talking about. I thought we'd talk about OpenClaw a little bit more, honestly, but I think it's fine that we.
Yeah, maybe we'll talk a little bit more about that in break, because I don't know. To some level, I don't want to advertise these garbage things, but then to another level, I do want to warn people about the dangers of things like this.
Yeah.
So it is nice to talk about it.
I think the thing I'm really excited about is like, what is the next Mac Studio Ultra chip going to look like? Like, is it going to be
excited to see
M4
that,
or is it going to be an M5? The rumors I've read a little bit seems like they're just going to realign, so there won't ever be an M4 Ultra. They'll just go to M5 Ultra. But I really wanted to know, like, A, is there going to be like a 1 terabyte of RAM option? And B, like, what's that memory bandwidth going to look like?
Yep.
Like, I imagine for the M6 and M7, they're already planning on having like an absolutely gigantic amount of memory bandwidth, just to be like, oh yeah, now we can actually go toe to toe, or really outpace what NVIDIA can do, but locally, 400 watts or 300 watts, right? But even if I could get the same, I mean, I imagine it's probably going to be like maybe 900 gigabits per second. Maybe they'll bump it up to a terabyte per second of memory bandwidth. That'd be really cool. But like, just what you can do with like that much bandwidth with that much RAM, like you could actually have something that competes with the Frontier model at probably a pretty decent token per second, like maybe 20 tokens per second or 30 tokens per second. And if you can run that locally, and like you still have like some space for like your computer to do computer things, and now you don't have to like have a subscription or go off your machine or any of that, or pay for an API and get the same quality or better quality. Like KMK 2.5 beats Opus 4.5 and ChatGPT 5.2 in like a number of things. So it's like, oh, like there could be a world where we actually do have like local AI. I mean, it's going to cost you a boatload of money. Like this machine is probably going to cost like 13 grand or something. But like, that's something you can actually run locally compared to like APIs. And of course, like the thing people will say is like 13 grand, like even with API subscription, it takes you so long to exhaust yourself through that. It's like, yeah, but like you amortize it over years. Like if KMK 2.5 is good enough for you today, I think as Steve mentioned this, like it's probably going to be good enough for you for a couple of years. And you might have some envy of like, look at those other models that are slightly better. But also there'll be other open source models that are just as good, if not better, right? Like it'll continue to go, and like having a machine that has this much bandwidth and this much RAM is going to get you far for a very long time, because there is no consumer setup that will get you anywhere near this amount of RAM with GPUs. They just don't make consumer GPUs with this much RAM, right? They don't really make commercial GPUs with this much RAM. Like you really do rely a lot on the NVLink, the switching infrastructure of those commercial servers to get the connection between the GPUs that gives you the high bandwidth you need to do API models. But with Apple Silicon, it's just like a little unified thing. I mean, today we already have 800 gigabytes per second, 512 gigabytes of RAM. Like if I had that right now, I'd be able to do a lot of what I want to do at really good speeds. So it's like, what we have right now is great. What Apple's going to release in a few months will probably be even better. I do think that this is going to start to meaningfully shift the landscape as time goes on. It's going to start really expensive, but it'll drop down, right? I mean, even having 128 gigabytes of memory on your MacBook Pro will let you run some pretty big models. And that's only going to cost you like a few $1,000s, I think. It's not going to be prohibitively expensive. In fact, let's look it up right now. I'm going to look this up right now. What is a MacBook Pro with what's the max amount of RAM you can put in one of these things? Okay, so if I do like
128.
Oh my god, there's so many options you have to select. I like it better on the phone when you don't have to select all this stuff. So you can get up to, oh my god, there's so much clicking here. Yeah, up to 128. So they'll probably bump up a little bit more, but that's still like an insane amount of RAM.
Yeah, I mean, I think MacBook Pro goes up to 192. I think MacBook Pro goes up to 192, and I think.
Or wait, I was just looking at MacBook Pro. Hold on.
I think Mac Studios have to go up to 1 terabyte at some point.
You know, I was talking to my friend about this like middle of last year, and I'm just like, I want an M3 Ultra 512 gig MacBook Pro or Mac Studio, but I just don't know what I do with it. Like, who would ever need that much RAM? And now I'm sitting here being like, man, I wish I had something that had 2 terabytes of RAM in it. So it's like,
yeah, you don't realize how important it is until you want to load a model, and then you're like, wait, this model is 200 gigabytes. Like,
yeah. And
okay,
it needs to be in RAM for it to run well.
Yeah. So there goes a quarter of my RAM automatically, you know?
Yeah.
Yeah, it's again, it's wild because just a few years ago, like 16 gigs was enough. You know what I mean? 16 gigs really was enough.
Yeah.
And now it's like, I don't want to see anything below like 48 gigs of RAM. I don't even want to touch that machine. You know what I mean? Like even my wife's MacBook Pro has 48 gigs and she doesn't need any of that. But like, what am I going to do? Put her in the 1624 model and then like, oh, something, you know, the 3 years along the line, it's like, this needs more RAM and I can't upgrade it. Like, no, I'm just going to get higher RAM from the get. It's fine.
Yeah.
What's $200-$300 across, you know, across like 3 years of ownership or whatever, 4 years of ownership.
Yeah. And like, the more I think about it, I'm like, yeah, no, if I had like 2 terabytes of RAM, I can run multiple different large models at the same time. And then it just becomes like down to like scheduling and using bandwidth appropriately. But there's like so many interesting things that you can start doing. I just think none of us were prepared for a world in which like there was something that you'd run locally that does need 200 gigabytes of RAM and all of it needs to be memory at the same time. Like that's just not, I don't think there's really been anything so far where that's been like what we've needed. I think there's been things where it's like, you know, where that would be helpful, that will accelerate things. Maybe there's like some databases in the past that you like, it works better if you can fit everything in RAM. But like nothing where it's like, oh yeah, if you don't put this all in RAM, then good luck. Like good luck. But again, if you can get storage bandwidth that is as high, right? If you could get, I don't know if it's even possible, but if you could get like a storage controller bandwidth, right? If you could get between the CPU and like your storage controller, or I guess the storage controller on the actual chip, or you know, that bandwidth up to like 800 gigabytes per second to like your SSD, I think that would also change a lot of things. Yeah. Because even though SSDs are expensive, getting a terabyte SSD is a lot cheaper than getting a terabyte of RAM. Right.
Damn right it is.
So
dude, damn right it is, man.
Opening up that would be, and I'm sure there's lots of technical reasons why that would be very difficult to do right now, but there's like, at the end of the day, all of this is just different configurations of silicon. I'm sure we can figure this out.
Yeah, I think the PC as we know it of building it, I think that has to shift. I think we're well past it. I think we're well past what it was originally designed for, like this whole ATX form factor plus CPU plus seats. I think that has to shift a little bit. And I hope it does.
I think it's been shifting, right? Like it used to be that the board itself is shifting, right? The board used to have like, you had your processor and there'd be like the Northbridge or Southbridge. One of them would be like a separate chip on the board, and you had all these different chips. And slowly all of that has moved into the processor. The thing that hasn't moved is like the RAM itself. But I think that's largely because we've kept this architecture where you have like the processor over here and the compute over here and the memory over here, and you have this thing in between. And really, we should figure out an architecture we can put all of that together. So you have a lot more cores that have a lot of memory like right next to them. And then you can do like a much more interesting computing. But that would require us in the software world to change how our software works. Because right now we are very low core count focused. Like even Go, I mean, maybe it's better now, but like the Go scheduler like years ago couldn't really handle above like 100 cores, I think it was.
Yeah.
Like if you started getting above that, it started getting not great at all. So it's like we're not ready for the world in which we have 400, 500, 1,000 cores for a CPU. And that is the world we're heading to. Like the newest AMG chips, I think, top out at having, I think, like 192 was it threads? Or maybe it's 96 cores, 192 threads. But we're going to get above 100 cores real soon, and we're going to just likely keep going higher and higher and higher. So it's like, okay, what do we do in a world where we have massive parallelism and a whole lot of concurrency, but our software is all built to use none of that?
Let's do break.
Okay. The break. Verse and outro. So, listener / viewer, switch it around there. What did you think about that conversation we just had? Do you agree with us? Are you excited about the future? Do you think this RAM shortage is going to last forever? Do you think that we're going to be paying twice as much or 3 times as much for RAM in a couple of years as we're paying now? Or do you agree with me? Or do you think that's probably going to, we're going to be paying half as much? I really hope we're paying half, a quarter as much, a tenth as much, something lower than what we're paying now, hopefully drastically. But let us know your thoughts on social media, in Change.Zulip, Go for Slack, or wherever you might find your lovely Fall Through host. This episode of Fall Through was hosted by Chris Brando with co-host Matthew Sanabria. Fall Through is produced by Chris Brando, and our beats are by Breakmaster Cylinder. So close. So close. And we are recording. Okay. Do a little intro.